Hey everyone, welcome to day 5 of Math 133. Today we're going to talk about the Chapter 3, Project 3. And you only have one lecture note to do, which is the 3.5 lecture note. So, Chapter 3, Project 3, we're going to be looking at the 5 number summary. Okay. And we're looking at box plots. I'm recording this right now. On Thursday, I have the recording for the morning session, but I want to point out that there's only one there. Usually, I try to post both the morning uh, Zoom recording as well as the evening, but there's times where I'll only put one in there. Maybe I said something that one went better than the other. So if that's the case, you can watch either one. It's the same material. So on Thursday last week, I was having some internet issues in the evening. So I just, it went, it was pretty rough. So morning, internet's fine because everyone's at work. So it's when everyone's home and using the internet that everything slows down. So you guys are making the right decision being on the call for the morning. So uh, okay. Anyway, if I do get kicked off for internet issues, that'll show me for saying morning's better. So for internet, but anyway, okay. So for today, chapter 3, project 3. If you click on the link in Canvas, it'll bring you here. And there is a link for the Google document, so you want to make sure you click on that. There's also a video here if you want to watch the video, but just like with our other projects, we're going to work on these together on the Zoom, so you don't need to watch that video. All right, so when you click on that link, it brings you here, and I'll drop this in the chat as well. This is our Google document where we're going to be filling in our answers, but you can't fill in here. You have to do File, make a copy, and you don't have to rename the date, but it is spring 2026. Put name in there. Change the folder where I'm saving it. So you can put it in your My Drive if you want. Make a copy. Okay, and now let's start filling in our answers. All right, so today, uh, similar to the other projects that we've done so far with StatCrunch, we're going to find a publicly available data set on StatCrunch that is interesting to you. Your data set needs to have a quantitative variable, okay, with lots of numbers, variability, and repetition. Uh, so remind me again what quantitative is. What was a quantitative variable? Numbers. Yep. Countable numbers. Yep. So they don't have to be whole numbers. They can be decimals, but they have to be something that you can do math on. So, okay. So let's go to StatCrunch.com. So type that in StatCrunch.com. In the upper right where it says sign in and register, you'll want to click on that and then sign in with your Pearson username and password. Once you've done that, it's going to bring you here, and we're going to click on data sets over here on the left. Okay. And just like before, there's lots of data sets here that you can use. And we just need one that is quantitative and it needs to be something that you're interested in. Yes, you can use the same one that you've used for the other two projects if you want. I'm not going to. I'm going to use something new this time. Uh, so I've told you guys before, like I have a board game I made called Endangered. where you save, species. So the environment is very important to me. So I'm gonna look up like carbon emissions. So let's see, this one, what's this one? Carbon dioxide emissions from fossil fuel burning in the top 10 countries. So this would work. I could do China or the US. What about this one? What does this one look like? Atmospheric carbon dioxide. Okay, I think I'm gonna use this one. Okay, so let me close the other ones so I don't get myself confused. Okay, so question one, what data set did you choose? So once you've picked a data set that is interesting to you, you're going to copy the URL. So go up to the address bar, highlight everything there, hit Control C, or you can right click and copy. And then come over to our Google Sheet and right click and paste. Okay. Treating your data set as if it is a sample, find StatCrunch statistics output that include only the 5-number summary, the range, and the interquartile range. Hint, there should be 7 numbers, okay? So we don't want everything. We don't want the mean sample size and all those different things. So um, does there need to be more than one column? Kelly's asking. No. I have a couple different columns, but I'm going to use just one. You need one quantitative column, so one column with numbers, okay? Um, if you have lots of columns, that's fine, but that's not going to be necessarily helpful. So like if I had done, uh, so let's do this stat. So let me look up a different one. So if I had looked up emissions, um, so this one right here is probably not good because the size is not very big. Same thing with this one. So this one right here is probably not a good choice for our data set today because I'm going to choose a single column, and this one only has 18 numbers. Okay, so you want to have, as it said in the project, you want to have a quantitative variable with lots of numbers, variability, and repetition. Okay. So you probably need at least like 50 numbers. Okay. Because remember what the 5-number summary is. The 5-number summary is going to find the middle number, which is in my case would be like this one right here. And then it's going to find first quartile and second and the third quartile. So like there's not really much difference from here to here. There's only 3 rows. So but no, you'll need one column of numbers. Okay. Okay, so all right, treating your data as if it's a sample, find the 5-number summary, the range, and the interquartile range. Okay, so let's go over here. This is the data set that I'm using today, and we're going to go stat, summary stats, columns. Stat, summary stats, columns. So Sal's asking, can it be on any data set in StatCrunch? It needs to be a data set that has a quantitative column, and that quantitative column needs to be, at least 50 numbers or so. So all the data sets that we've been using so far, like the superheroes and the Thanksgiving, the wedding one, those will all work. All right, so you need to select your column. So I'm going to be looking at CO2 emissions. And then I'm going to come down here and I'm going to select the 5 number summary. Now, uh, it's already got a couple things selected for me in the white box here, but I don't want all of these. I only want they said 5 number summary and then the range in the inner quartile range. So there should only be 7 numbers. So if you click on the box on the left in gray, you can select which ones you want. So let me ask, what numbers are in the 5 number summary? Somebody tell me the 5 things in the 5 number summary so I can go find them. So quartile 1, 2, 3. All right, so there's quartile 1, mean, median. So not the mean. Mean is not in the. So we do want the range, but the range is not part of the 5 number summary. So there's 7 numbers we're going to get. We're going to get the 5 number summary and the range, which is not part of that, but we are going to get that one, and the interquartile range. So we're going to get 7 numbers. So the 5 number summary is 5 of them. The range is one more, and the interquartile range is one more. Standard deviation, nope. So the 5 number summary is the minimum, and I'm going to hold my control button down, the maximum. It is quartile 1, quartile 3, and then I'm going to let go of my control button and scroll up here to the median, okay? These are the 5 numbers in the 5 number summary. Minimum, maximum, quartile 1, quartile 3, and the median, okay? Now, I don't care what order you put them in, but by definition, the minimum is the lowest one, so that one's always going to be smallest out of those 5 numbers. And the maximum will be the biggest. What's the median? What does median mean? Does anyone remember what the median is? Yep. So Kelly's pointing out median is the quartile 2. It is the number right in the middle of your data set. Okay. So if I wanted to put them in order, and you don't need to, but it would be minimum would be the smallest, and then quartile 1, and then the median, and then quartile 3, and then the maximum. Okay. So minimum is always smallest, maximum is always the biggest, median is always directly in the middle, and then quartile 1 and quartile 3, those will break your data up into quarters. Okay. So go ahead, Kevin. What's your question?
So real quick, I'm clicking on median, minimum range, Q1 and Q3. Every time I click on median and go to click minimum, it selects range also. So I have
That's
median,
because you're,
range,
yep,
min, Q1.
that's because you're holding the shift button down. If you hold the shift button, it'll select everything from the top to the bottom. I've been using the control button to select them one at a
Control, that's
time.
what it was. Got it.
But that's okay. We do want the range in this case. So I'm going to hit the control button and hit range as well because the problem said we want the 5 number summary as well as both the range and the interquartile range for this particular case. So, but the interquartile range is a little farther down, and that one you need to use the control button because if you use the shift button, it'll also include the sum, and I don't want the sum. So, okay. All right. So I've selected the 7 numbers that I want. Okay. And then I'm going to hit compute, and we'll see what we get. Okay. So here's my 7 numbers. Again, I put them in order from smallest to largest. So 313, 326, 340, and then 390 is my largest. You don't need to do that. You just need to have all 7 of these uh, numbers selected. So, all right. And then we're going to copy and paste this table into our Google document. So I'm going to click in the upper left and then left click and then drag it down to the lower right. So I can select everything there and then you can copy it and just paste it right in here. Okay.
You wanted INR also, correct?
I do want IQR, yes. The interquartile range, yes, I want that as well. Okay. So now that I have that, question three, what is the value of Q2 for your data set? So looking at my screen, your numbers are obviously going to be different than mine, but what is the Q2 for my data set? Kev says, yes, it's the median. So for me, it's 343.46. Yep, it's the median, yes. So the median has a couple different names. The median, which means it's the middle number, okay? Uh, Quartile 2, so Q2. Um, so quartiles 1, 2, and 3 will split your data into 4 quarters, right? Um, so Q2 is basically where 50% is, right? Two quarters makes 50 cents, right? So uh, that's why we don't always call it the Q2 because we can also call it the 50th percentile. Okay. All right. Next, question four. Interpret the value of Q3 in the context of the situation. Whenever we see the word interpret in this class, it means we need a sentence. Okay. So part of being a data analyst, part of learning statistics is not just knowing how to do the math and, knowing what these things mean, but also being able to explain it. Okay. Uh, I do a lot of, math and statistics and reporting and all kinds of graphs and stuff at my job. But the people that I present those graphs to are not always someone that's mathematically minded. Like they might be running the company, but they might not necessarily understand the underlying statistics. And so it's part of your job to not only know the math, but also be able to explain it. Okay. So in this case, uh, I have quartile 3 is 363. What does that mean? If I told someone, well, the 70, the third quartile is 363 for these emissions that I've got, the carbon emissions I've got, that's not going to be helpful, okay? Because if they don't know what that means, like yeah, that's not going to go anywhere. So we have to be able to explain it in layman's terms. So, yeah, so my question is, so what percentile is quartile 3? So, Kevin's saying that it is 75th percentile, right? How much money is 3 quarters? 3 quarters is 75 cents, correct? So that means that the third quartile is 75%. Okay. 75% of what? 75% of, so let me look at my data set here. So this data set that I'm looking at, each row represents what? Each row represents a year. No, it's not representing a year because I've got 1958, 1958. So each row here is representing a month for me. Okay. So this is March 1958, April, May. Looks like we didn't measure in June. Okay. But that's okay. So for the months that were measured, we got these CO2 readings. So the 75th percentile is measuring 75% of the months are below a certain number. Okay. So that's what I'm saying here. So 75% of the months measured. Now, for you, what does each row represent? Each row is not going to represent a month. Okay. If you were looking at the superheroes data set, then each row is a superhero. So 75% of the superhero is measured. Okay. 75% of the days or whatever each row, what does each row mean? Okay. Okay, so for this one, each row is a month, and for 75% of the months measured, had a CO2 reading of 363.24. And then, do I need units on this? I'm not sure I have units. Or lower. Okay, so that's what I'm gonna say.
These questions are where I struggle the most at right here because it says my median's 18.
Okay.
I'm doing the box office one.
Sure.
18, is it million? Because I'm using budget and it's in millions, but it doesn't make any
Yeah.
sense either. Because like 425 million is being spent on Avatar.
Yeah, so you would say 75% of the movies in the data set had a budget of $18 million or lower. So, yeah, there's 25% of your data is still going to be above that number. So, Avatar would be a way above that, right? So,
Oh, there are smaller numbers. It's just way down. I have like 100, 200 movies, so that makes sense now.
yep. So, yeah, Avatar is one of the movies, and that one's probably an outlier. And when we look at the graph, you're going to see that it's way off to the right. Okay. We've talked about outliers a little bit, but we'll definitely see them more today here. Um, so for me, uh, I don't I don't have what my units are here. So I'm just going to leave the units off. I'm not going to. Oh, wait, maybe I have it here. Emissions figures are in million tons of carbon. Okay, so um that's all right. I'm not gonna mark you off if you don't include the units here, but I mean the units do make it more understandable, right? The whole point of interpreting this is, you know, if I'm presenting these numbers to my leader or presenting these to Congress or whatever, I want to be able to explain what this means. If I just say 363, is that pounds? Is that tons? Is that what is that? Don't forget the word or lower, okay, or less. Either one's fine, or lower or less, less than or equal to. Because when we're talking about percentile, it can be equal. Okay. All right. So that's what I'm going to put for number 4. Uh, Number 5, construct a horizontal box plot of your data with StatCrunch. Check the box, draw boxes horizontally. Okay. All right. So let's go back over to StatCrunch. Okay. And you're going to hover over graph and then box plot. Okay. Select the same quantitative column that we've been using. Okay. And then right here, we're going to click draw boxes horizontally. And we'll hit compute. Here's my graph. Okay. Now, why did I want it horizontal? If I had done my graph just normal, if I do a box plot here and I don't do it horizontally, it's going to draw it vertically, obviously. Um, that's fine. The issue is that we are going to be talking about skew left and skew right, and it's a little harder to tell when it's vertical because, well, I guess it's not left and right anymore. It's skewed up or skewed down. So that's why I want to do left to right. Okay. All right. So here is my box plot that I have. And you're going to obviously have a different looking one, and that's great. That's fine. Okay. Um, so what is this? Well, what is this box plot? So this box plot is measuring the five number summary, these five numbers. Okay. So for me, my minimum was 313. This line right here represents 313. Okay. Here's my x-axis with my CO2. Yes. And so 313 is right around here. Okay. So this is the lowest number. This vertical line right here represents quartile one. Okay. And that is at 326, which is right around here. My median, 343, is right around here. So that's this middle line. Okay. And then this is quartile three. And then this line way over here on the right is my maximum. Okay. So what's happening is I have lots of data. It's all over the place. What have I got? I've got like hundreds of rows of data here. Okay. So the the five number summary is it's a summary. It is basically taking this giant set of data and making it a little easier to understand for us. Okay. Now, we've talked already about center and spread. Okay. When you have a giant set of data, it can be hard to wrap your head around it. And so there's times where we say, okay, I don't want the whole data set. Just give me the average. Just give me the middle number. Just give me a normal number. Okay. So like if I asked, you guys are uh, working on your degrees and hopefully, you'll graduate and, if you're in the nursing program, you'll be able to move on and get a job. How much money are you expected to make? Because you want to be able to plan for your life, right? You want to be able to budget. Well, if you look at, nurse incomes, there's lots of nurses and they all have a different number. So you don't necessarily want to know all that information. You don't want to have, millions of numbers in your data set. You just want to know, well, what can I expect? What's the average number, right? What's a normal number? Okay. So that's what summarizing your data is. Okay. Or, there's obviously outliers and averages are very affected by outliers. So maybe you want the median. Give me a middle number. Okay. But that's even not necessarily what you want because if you're planning on going into nursing and you're doing so in Michigan, uh, you're going to have a different salary than someone who lives in as a nurse in like Hollywood, California. Okay. So even then, you might not necessarily want to know just the middle number. You might want to know what the range is. So like, what's the minimum? Like, what's the lowest that we pay that a nurse would get paid? What's the highest? Okay. So by having these five different numbers here, you can plan things a lot better. Okay. Here's, what would happen if if I'm getting paid this number. Here's a normal number in the middle and so on. Okay. Now, the quartile one and quartile three uh, and the median break the data into four data sets, into four pieces. So the first piece is this white piece here, and then you have two blue pieces, and then you have another white piece here, which is the tail. Okay. So that's what is happening with the quartiles. Okay. All right. Now, I will point out, and like I've said before, like as a data analyst, as a statistician, it's our job to present the data and interpret the data and make it understandable. So box plots are one way you can do that. I will say that box plots are not used that often, partly because people don't know how to read them as well. Like today, I just told you that this line right here represents quartile one. Did you know that before today? Maybe you did, but you know, the majority of people I don't think realize what a box plot is showing. So I will say that box plots aren't quite as valuable as bar charts. Even pie charts are a little more readable than box plots for normal people. But that all said, box plots are super valuable when you are comparing two data sets. So if I was looking at, let's say I want to look at this one, okay? So this one is looking at China and the United States. If I was to do a histogram on this, and I selected both of these. There we go. Give me horizontal. Oh, well, that's because I selected histogram. That was dumb. Box plot. There we go. That's better. Draw my boxes horizontally. So this is a much more valuable chart than just the one with a single box plot. A single box plot, okay, I'm showing that, okay, so here's my single box plot that I've got. So I'm showing that like the median here is 313. Is that a lot? Is that a little? I have no idea. So having a box plot with where you have two data sets and you're comparing them makes it a lot easier. That surprises me you don't like pie charts. Elaine missed my rant in a previous class. That's fine. Anyway, so why I'm saying this is valuable is because you can see that like so for China, for a lot of the months, China was lower than the United States. But you can see that way out here, there's a couple of dots. These dots out here represent outliers. So um, this line right here. I said that's the maximum. It's not actually the maximum unless there's no dots. If there's dots, then your maximum is the dot that's farthest to the right. Okay. Um, anyway, so you can see that there have been a few months where China was higher than the US in terms of carbon dioxide production. So you can see that the US is much more, uh, you know, grouped together. So basically, over time, the US has been putting out more CO2 than China, but they haven't changed a lot. Okay, it's been pretty consistent. China, on the other hand, there have been a lot of months, most months, where China was below us in terms of CO2 production, but it's varied wildly, okay? Where sometimes they're very low and sometimes they're very high, okay? So that's very informative and interesting to see as opposed to a single box plot where it's like, is that high? Is that low? I don't know. Okay. Okay, so anyway, let's go back to our project and actually do things. Construct a horizontal box plot. We did that. And paste the graph here. Okay, so let's go get our snipping tool and copy this here. Grab that. And we'll paste it in here. Okay. So, Elaine, I apologize for hating on pie charts. So, um, charts of all types have valuable times that they are used. And pie charts, the most valuable time to use a pie chart is when you have two categories. Okay. Maybe three, but two is the best. Okay. Um, box plots are super valuable when you have two different quantitative columns that you want to compare. Okay. If I'd wanted to do this same where did it go? There it is. If I wanted to do the same chart with like a box plot, I'd have to do like a side by side box plot, which is readable, but it's not as readable. It doesn't give you as much insight as this visual here does. Okay. About, how China is usually lower, but sometimes higher. Yeah. So, all right. Anyway, uh, there's other charts, there's Sankey charts and tree maps and stuff like that that get real crazy where it's like, what is that? And if you use them in the wrong place, it can just make your message even more confusing. If you use them correctly, it can make it much easier to understand than just a normal bar chart. So, all right. Let's go on to number 6. Judging from the box plot, do you have any outliers? So, no. My box plot does not have any outliers. because it has no dots. Okay. Uh, the other one that I was showing earlier, the China one, I would say yes, China does have outliers because there are dots, right? Easy enough. All right. So I'll ask you guys, who's got outliers in theirs? I know, I know Kevin does. He said he's talking about Avatar. Yeah, Avatar is if you hover over that last dot right here. I'm curious if if it is that one out is that one Avatar or is there others that are even higher than that? So, Tegan says he's got some. Caleb, yeah. Most real world data sets do have outliers, okay? Because oh, Avatar is your max, yeah. So um yeah, because most real world data sets have outliers. There's always weird things. There's always exceptions, right? There's always movies that have giant budgets, and there's, people that have $1 million homes or, whatever. So, uh, and you have to, know how to handle those. Okay. All right, so question 7. Judging from the box plot, what appears to be the shape of the distribution for your chosen variable? Skew left, skew right, or symmetric? Now, we've talked about skewed left and skewed right before. We talked about it when we had histograms, and it was very easy to see because you could just, look at the shape left or the right. We talked about when you have the mean and the median, if the mean is bigger, then it's skewed right. I don't have the mean here, I just have the median. So the third way that we can tell skew left or skew right is looking at your box plot, okay? Basically, if your boxes, so this box right here is from Q1 up to the median, and this one is from from the median up to Q3. If the box here on the right is bigger than this one, then it's probably skewed right. Same thing with this tail. I've got this tail over here on the right. This is called the whisker. And then I've got this whisker on the left, which is a little smaller. So since the box and the whisker are longer on my right-hand side, I would probably say that mine is skewed right. Okay. Another thing you could say is you could say that it is skewed right because you have outliers to the right. So here, China is clearly skewed right because not only is the box bigger on the right and the whisker bigger on the right, but also it has outliers over here on the right. So I could say that China is skewed right because it has outliers off to the right. Okay. Looks like United States is skewed left. Okay, because the box and whiskers beard. Now, if you have a situation where this, let's say you had a situation where the whisker on the left is bigger than the one on the right, but the box on the left is smaller than the one on the right. Well, then it's not necessarily skewed left or right. Okay. In that case, you might say that it's symmetric. So you would say symmetric because uh, the size of the boxes and whiskers are not different between the two sides. Something like that. And again, it doesn't have to be perfectly symmetric for it to count as symmetric. Looking at my box plot, I would almost say that this is symmetric, okay? Uh, Definitely between the two boxes, I would say it's symmetric. This tail on the right, this whisker on the right is making me think it's probably skew right. That's a little bit longer, a little bit too long to be counted as symmetric, I think. By the way, the range is the minimum versus the maximum, so it's the length from here all the way to here. The interquartile range is the width of the box. So it's from this vertical line to this vertical line. Okay. All right. Lastly, question number 8. Judging from your answer above, what are the best measures of center and spread for your data? Okay. So there's two possible answers here. And that's it. Okay. So I'm going to write both of them out. So if you said that it was symmetric, okay, then the answer here would be mean and standard deviation. Okay. Because, well, because why? So we haven't talked about this yet, and we're probably not going to talk about power, statistical power in this class, um, other than just in a passing mention. But mean and standard deviation have more statistical power. And we're going to basically, once we get past the midterm and we start talking about z-scores and normal curves, we'll be talking about confidence intervals and hypothesis testing. We're going to be focused solely on the mean and the standard deviation, okay, for the second half of this class. The mean is the average, which is a way to measure the middle of your data. If I say, like, you know, what's the average budget for a movie, you would take all the numbers, add them up, and divide by how many numbers there are. The problem with average is that it is highly affected by outliers. Okay. So, as Kevin mentioned, Avatar had a huge budget. And because of that, when you average it, it's going to pull that number much higher than it would actually be. So, the median is a much better way to measure things when things are skewed, when you have outliers, okay? However, we're not just going to use median for everything, okay? Because mean and standard deviation have more statistical power. Now, we could have done, when we get to it, when we get to chapter 7 through 11, you could do confidence intervals and hypothesis testing using the mean or sorry, the median and the interquartile range. It's just that it's not going to be as useful. Okay. So anyway, so this is one answer. Um, Most of you are not going to put that answer because most of you have skewed data. So if I had, let's go back to what I had before. Skewed right because I have my outliers. Okay. If you wrote skewed, whether skewed left or skewed right, then you'll go with the other answer, which is median and interquartile range. Okay. The reason why is because they are resistant to outliers, okay, or skewing. They're resistant to skewing or skewness. Yes, that's a word. Skewness. Okay. I mean, any of those is fine. Okay. Uh, but the median and the interquartile range. are ways of measuring your center and your spread. So again, the center is what's a normal number, okay? So if I asked you, what's a normal CO2 production for a month, I would say that it's, whatever this number here is, 343, okay? Um, 50% of my data is below that, 50% of my data is above that, okay? Um, and it doesn't matter if I have outliers way off to the right. Each of those outliers is only going to count as one data point. Okay. And that's why median is resistant. Okay. Interquartile range is a way to measure your spread, how spread out your data is. Okay. Uh, and it is again resistant to outliers because it's based on the quartile 3 and the quartile 1. So interquartile range is the width of the box. It is Q3 minus Q1. So I can see here that China is more spread out because it has a wider box than the US. Okay. Now, range is another way to measure spread, but we're not going to be using that for anything. Okay. Because, first of all, range is very affected by outliers, okay, because it is the maximum minus the minimum. And by definition, the maximum is the most outlier-ish, and the minimum, same thing, is the most outlier-ish of your data, okay? Um, and then also with range, uh, it's only comparing two of your numbers, okay? So you might have, if I had the United States here had a very tight box and a very tight graph, but I had a single outlier way off over here on the right, it just messes the range up entirely. Okay. Just because of one number. Um, the other thing, so we talked about for center, we talked about mean, median, and mode. We are also not going to be using mode for center because mode is the number that happens the most. And again, that can really vary wildly with your data set. Okay. So so two answers for that one: mean and standard deviation, or median and interquartile range if it's skewed in any way. Okay. And I think that's it. So let's go ahead and click share in the upper right. Change our restriction to anyone with the link. Copy the link. Let's put it in Canvas. All right, so gotta be in the student. So in Canvas, chapter 3, project 3. Scroll to the bottom here, click on web URL, and we'll paste that in here. And submit assignment, get our confetti. I got stars this time. And we're done. Okay. All right, so don't forget to do the lecture notes here. And again, as I've said before, you are welcome to do to work ahead in the lecture notes. So you've already seen, hopefully seen that this class has a lot to do. Okay, we have an assignment and we have lecture notes all the time. So make sure you don't fall behind. The best way is to work ahead in the lecture notes. Okay. Uh, and um, yes, last time we did chapter 3, project 1, Kevin. Yep. We did mean, median, mode with StatCrunch last Thursday. So if you joined the Zoom, then you probably already submitted it. If not, it is due today. Um, and I'm going to stop the recording. If anyone has any questions, feel free to stick around. Otherwise, I will see you on Thursday. Elaine will see you on Wednesday. Try to read the 3.5 lecture notes before Wednesday because she's going to be using those. Okay.